So I'm the contractor, so now it's my responsibility to bring us back onto the schedule, like just as in real life as well. So we have heard about how we're creating models and creating content, how we use that to collaborate, some fancy tools for how we push this out into the field. And so I wanted to show a few examples of some real customers using this technology to do their work. So I have 3 cases. For sure we'll get to look at 2 of those at least. So let's just begin. So the 3 cases we have 2 from the UK, 1 from the USA, Barton, Malow, Solve Structural Design, and Mitchellson Formwork. And I put this wheel here of all this ways of using the model authoring tools and the collaboration tools just to kind of as a reminder. So think about this wheel when you're looking at how they're using the tool as well. So the first one is Barton Malow, USA. So some of the topics is this is their presentation, so I have not edited their presentation at all other than to put it onto the Trimble template. So some of these things I'll quickly go through because it's just some background things. They wanted to discuss how do they take a pre-construction model, so basic model they make when they're bidding the job, and turn it into something they can build from, show how the people in the field can use it, and also show how they're doing the production tracking of the work they're doing in the field. So I won't go through all of this, but suffice to say, Barton Malow is a large customer located in Detroit, what we call Motor City, where a lot of the car companies in the U.S. are located. And they do $2.4 billion in revenue, over 2,000 employees. This is just some examples of the work they do. This is one of my favorites in the bottom right-hand corner. That's a baseball field in my hometown. But you see they do industrial facilities, apartment buildings, office buildings, sports arenas, this sort of thing. So the first thing to think about with Tekla Structures as a contractor who is planning and pouring concrete is that the tool is very customizable. So the toolbars that you see here are toolbars that they made, so you can actually change the user interface to fit your needs. And these are the Formwork tools they've collected together and sort of have the user interface set up how they want to use it. You can even see they have their own icon for syncing the model as well. And then the database in Tekla Structures can also be customized. So this is what you see here. You can add this tab here and then whatever fields you like. And then that information can also be synchronized with Trimble Connect. So it's a way that they can link their cost system, with their accounting, but also their production tracking out in the field. So now the fun part. So we start to look at some pictures. So this is a project that they've modeled, and they want to get the concrete quantities and the areas, the volumes, etc. So it's interactive. So when they make the selection in the model, then they get the quantity information in the object browser, which Yuka touched on. Then they can export that to a spreadsheet. So you see this group code information here on the left. That's all the cost code from their accounting and estimating system, so they can make the link. So that's closing the information loop with the accounting part of the business. So just some screenshot of what's happening in the drawing and how they translate that into the model. One thing that they do use heavily is our patented technology for pours. But we had the question before, how do we incentivize people to use the technology? Well, this is an example of them bringing the field person to the office, which is you see here, and he's using the big screen and explaining this is where the pour brake should go. And then we have a Tekla Structures user here placing the pour brake. So the young people and the experienced people and the sort of technology people and the field people are working together to make the plan in the model. So here we just have some 4D simulation of the project. So another thing that they do is they do their own rebar detailing and their own rebar fabrication, and they're doing this using the same model that they did the pour planning with. And then It's not quite, as Yuka said, with only pushing one button, but they have this semi-automation, highly productive rebar shop drawings coming from the model, and these are just some examples here of the rebar schedules and the rebar shop drawings that they're creating from the model. And the pours are essential for that because the pour helps automate the drawing process. You can control what's on the drawing, what's not on the drawing. They're also doing some of their formwork detailing in-house. So it's used to help the field personnel better understand how this formwork is fitting together before they go to build it. They get very accurate quantities, and then they can generate the formwork drawings from the model also in a mostly automated way. So here's just some examples of the formwork drawings here. So again, the contractor is able to take more control. So they don't have to get into a line or a queue with the rest of the contractors. They can bring these things in-house and control their own destiny, so to speak. Another thing is embed coordination. So we have all the reinforcing, we have all the embeds, and we need to understand, do these things fit? Because the embed needs to go in a specific location. We also need the reinforcing there. So does it fit? And then also, can we place the embed in the correct location on the project? So they use the integration with the total station to ensure that they place the embeds correctly. And we had one customer that made a joke that before Tekla structures, it was like if you take an embed and put it into the ready mix truck and let it spin around, and then just casting the embeds with the concrete would be better than the traditional way. But now with Tekla, they actually have some understanding of where everything's supposed to go. They're also doing this so-called civil modeling in Tekla structures, so they're modeling the excavations for the footings and walls, so they can calculate what is the quantity of excavation they need to do for the foundation, how long it's going to take, and this sort of thing. So in the field, as I mentioned, we have this layout manager and point creation in Tekla structures, and then we can synchronize that with the total station, and this is just an example you see here. So they had a case where they took over a job from another contractor. The footings were already poured, the foundations were already poured, so they needed to do a survey of what was in place, and what they found was something different from what was on the drawings. So it's not only sending the points from the office to the field, but also bringing some points from the field back into the model as well. So you see, and then they were able to model the difference between what they found on the site and what they expected to find. They're also using Trimble Connect heavily to push this information and these models out into the field, into the hands of the people that need it. They're also tracking the production. So they're able to track the production in the model, what is done, what is not done, which you can see on the booth out here. And we'll see some examples as well. And then they're using Power BI from Microsoft to present this very nice sort of dashboard of what will be poured and then what has already been poured. And then they're synchronizing the model. You see some animation there across all the project stakeholders, so everyone can see the status and the progress of the job. Okay, now on to Mitchellson in the UK. Mitchellson, they call themselves Formwork and Civil Engineering. They're basically a contractor that's planning and pouring concrete on the site, and they're doing some sophisticated jobs, but also some basic jobs. So this is the Battersea Power Station. This is an old power station in London that they're converting into a space where people can live and work and shop and do those sort of things. We have the Royal Albert Docks project, and then a job in Knightsbridge. If you visited London, that's in a very expensive part of town. So why did they choose Tekla? Well, this BIM Level 2 industry standardization, it's a push by the UK government for the design and construction world to use more detailed models. And being that that's our specialty, they chose us because we know how to help make detailed models. There is a case where the industry is moving forward and wanting to collaborate in this way, but not to be forgotten is that they see benefits for themselves. So even on a project where no one else is using BIM, it makes them more productive, and they use it even on those projects because they're able to do things more efficiently. So how are they using Tekla? In the first place, they're using it in pre-construction for quantity takeoff, for scheduling the project, collecting information from the past and applying it to this current project, and then visualization of the project. So you're seeing of the progress. So you're seeing a theme recurring all the time. We want to track what's going on. What is the situation picture, as Yuka calls it. So they were heavily concentrated on using this pour technology to arrange the pours on the job and then extract the quantities. Because it's one thing to take the quantities for budgeting, but also you need the quantities for ordering the concrete on the site, which can be very time-consuming for the site personnel to do. They can quickly react to design changes and have that filter down to the field, the quantities they need to order. So one of the things that they're doing to bridge the technology gap is if a person if they feel they cannot handle the model, which we think everyone can handle a model, but if they have a feeling they can't handle the model, what they're doing is using our Excel integration. They make a quantity spreadsheet, and then they take a screenshot from the model and paste it to the Excel. So the person who's viewing it has a connection between the quantity and the actual part of the project in 3D where it's happening. So here we just have general pour layout for these foundations. So now we get to the good and bad. So they say some bad things about Tekla. So I hope everyone here can handle to hear some bad news, right? But it's mostly good. I have good news. So what are the good things from their experience so far? Well, they've heavily decreased the concrete waste. So you don't have people on the site ordering more concrete than what they need. They're able to do better planning. And so because they're working more efficiently, it's definitely reducing the cost that they're spending to build their projects. So they do some really complicated projects, particularly like Battersea Power Station, and they had a complaint that it took longer than they wished to get the pour breaks exactly like they wanted them. And the logic system was joining things in a way that they didn't want. So I can report that we have corrected this. This is kind of older presentation. So the point being is that we do listen to the customer. So they say, hey, we wish it would work in this way. We definitely take that on board and do that. So here we see they're using for planning and programming Ask the Power project, which is really popular in the UK for scheduling, and integrating that with the task manager in Tekla Structure. So they bring in the schedule, connect that to the model, and do some checking and planning. And the nice thing about the task manager is it's based on quantities. So it's able to calculate if you have a certain production rate, can I actually achieve what I want to achieve from a time standpoint? So what were the findings on planning and programming? Some of the production planning that they did in Tekla didn't match their traditional production planning, because the traditional production planning is so rough, so it's not detailed. And so they're thinking, wow, now I can have a better understanding when I have a more complicated project or in some different cases, is my estimate really accurate? So that was a big eye-opener for them. So it's allowing them for better planning in future projects, and again, reducing the cost. And maybe if they have a better idea of the cost, maybe they lose a project. It's a good thing to lose the project, because they would lose money if they took the project. So they're having some really good understanding of what the costs are going to be. So this is some things. There are some limitations with how we're calculating the production rates. And we're looking into what we can do about that. They want some more sophisticated calculation related to the production rates. So definitely looking into that. So not to be discounted is the visualization capability, just being able to see it in 3D instead of everyone individually trying to understand it in 2D. So what do they want to do next? And my understanding is that they moved on to doing this. They want to model temporary works, or better said, formwork and scaffolding, to speed up the process and not have to wait in the queue to get the drawings. They want to do better planning for future projects and staging the production. And they want to push the models closer and closer and closer to the site where the work is happening, right to the work face. And they want to start to use more the visualization of the work progress. So what is the state of the project at this very moment in their leadership and planning meetings? Okay, so now we have solve. So we might get through them all in the next 6 minutes. So solve says structural design, but mainly what they do is detailing. So they're doing detailing, and they do it for easy projects and hard projects. Let me just animate all this. Okay. So in the old days, they were using AutoCAD and a tool called a CADS RC, which is a rebar detailing program built on top of AutoCAD. They had a really strong desire to move to 3D, so they tried Tekla, Revit, and Allplan from Nemechek. And they came to the conclusion, I won't say anything negative about some competition, but they came to the conclusion that Tekla was very, very far ahead of everyone else in this area. So not only in the modeling, but also in the ability to create drawings and rebar lists and schedules. So they've been using the tool for about 5 years, and this is their landscape of what they use from us. So they use Tekla Structural Designer, which is our analysis and design tool that is available in some countries around the world. Obviously, Tekla Structures. They use SketchUp for some freeform modeling and sort of complex geometry cases. They use Tekla model sharing, so many detailers can work in the same Tekla Structures project at the same time. And then they're also heavily using Trimble Connect to not only collaborate internally, but also with their customers and partners. So this is some picture with the logos of how they're doing the collaboration. So at Solve, they're using Tekla Structural Designer and Tekla Structures, and consulting engineer is using whatever they use. Main contractor, concrete contractor is using Trimble Connect, and then the people installing the rebar are also using Trimble Connect. So what's the benefit of Trimble Connect for third parties, meaning people they work with who are not Solve? The full site team can make comments and sort of be in the model at the same time. The model becomes the center of the story during the site meetings. They can mark up changes, and they can identify problems a lot more easily than 2D. So internally at Solve, they get a visual overview. They're able to manage the information traffic. So information going out, information coming in, it's much easier to keep handle on what that is. And then generally speaking, supporting the workflow. So this to-do system in Trimble Connect is really good for managing, okay, what is the task we need to do next? And then these are just some of the UK clients that they work with. So you'll notice some main contractors, some civil contractors, some engineers, some concrete contractors. So when are they using it? You see here, we don't have to go to all the details, but pretty much every stage. So when they're bidding a job, when they're designing or detailing a job, and all during the construction stage. So they're using Tekla to produce drawings of the rebar, but also to send the information directly to the rebar fabrication systems as well. So no human hands touching the rebar information between Tekla Structures and the machines making it. Issues avoided. This is just some screenshots. So there are some projects they're working on right now that have like hundreds of thousands of couplers. And couplers are very expensive, so they're managing that and understanding what is the clashing situation with the rebar in this heavy reinforcement cases. Are we missing some reinforcement? Is there some place where the rebar is so dense and so heavy that the concrete can't actually go through? So they're checking these kind of cases. This is a Raft model, so you see the model there of the Raft slab, and then you see the real picture there. They also have some shear rails that they have to coordinate with the rebar also. So they also having some future ambitions. They want to work with the contractor so that they can order the rebar from the model. So a contractor can go into the rebar model and say, this is the rebar I want next, rather than doing some manual process to request the rebar. And then, like you heard from Yuka and also Kim, they don't want to make any drawings at all. So we had one project, I won't name the project, but they told us that it's in the UK, it's requiring 2,000 pounds or some 2,200 euros per drawing to create the rebar shop drawings. And there's some tens of thousands, maybe 20,000, some crazy number, rebar shop drawing on the job. They're spending anywhere, their guess was we spend anywhere between 20 and 40 million euros on the project just for the rebar shop drawings. So maybe you can guess what kind of project that is. But the point is, you could save that money if you didn't need the drawings, if you could use some technology like Yuka and Kim are discussing. They also want to laser scan the rebar so they can record how it was actually installed relative to how it was detailed, and then using augmented reality headsets for rebar installation and checking. So something like this here. So wearing the headset and pre-tying the rebar based on what's happening in the headset. And this video example is from Celsa Steel in Sweden, actually. It's not made by us, so just some current projects there. And then I won't show this Hinkley Point because Kim already touched on it, and then I'm not allowed to show some of the screenshots that they provided. So with that, almost right on time. So the contractor, again, has saved the day. So.